Get a good mustache twirl going here. Oh, pretty good. All right. Welcome back to Section 5, Plate Tectonics in Arizona. So how does shifting tectonic plates help to shape Arizona? I believe this is going to be our last section. Now, again, moving forward, I won't typically do this. You know, we're still trying to get used to the classroom format here. And remember, hidden within these lecture videos might be or will be a super secret code. Sometimes I'll say it. Sometimes I will just show it on a board. So if you're looking down here, hi, you look at me. Hi, hello. Here's the super secret code. All right? Here's the super secret code that's going to help you access the assignment. Now again, I'm nice, so what you might see in the future is I might not even say, hey, here's the super secret code. I could just be talking about, well, plate tectonics in Arizona and blah, 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 blah. And then here's the code. You know, I won't even say that. I'll just kind of like show it. I might make myself a little bit bigger so you can see it. So what I'm trying to do, again, is make you accountable, give you the respect you deserve in that ensuring that your lab groups and the people you will work with have the same baseline knowledge as you do as well, because you deserve that. You deserve to be in a group with the people that put the same amount of work as you have in. By hiding these super secret codes, embedding them in these lectures, I'm kind of somewhat forcing people to make sure that they watch, listen, and pay attention to these videos. Okay, so in any case, that was the super secret code. Let's talk about, please continue to watch all the videos throughout the end, even if you think you have the super secret code. But like I said, I'll be nice for now, and I'm telling you that is the code for the assignment. But this last section is pretty important. I like to focus on Arizona, how what we're learning is what we see and can touch and feel around us here in Arizona. So, plate tectonics has really shaped Arizona, and Arizona is a pretty unique state in that there's 3 geologic Arizonas. I want you to think about it. Think about Phoenix and the surroundings. Think about Flagstaff. Like really 2 different geologic settings going on. And then think about a place like Payson or Sedona or Prescott if you've ever been there. These 3 areas all look pretty different. This is known as the 3 geologic Arizonas. So up north, you have northern Arizona, which is part of the Colorado Plateau. It's a plateau is a high, flat-ish area. The Colorado Plateau exists in Arizona, up in Utah, Colorado, and New Mexico. So on the most part, up there, up in northern Arizona, it's mostly flat. You do get some different geologic formations, volcanoes as well, especially in the Flagstaff area. But for the most part, it's kind of a high, flat area. And then down south here, you have what's known as the Basin and Range Province. Phoenix is located right in this area here. This is Maricopa County. Phoenix is right here. Here's the White Tank Mountains. Here's the Estrella Mountains, Salt River, Gila River. Phoenix is right here. So Phoenix, Tucson, Yuma, all of these places, the geology looks pretty similar. Kind of flat with kind of mountain ranges popping up here and there. Flat desert, random mountain range popping up. Flat desert, random mountain range popping up. It's called the Basin and Range Province. In between the 2, we have the transition zone, going from the Basin and Range Province to the Colorado Plateau. So it's kind of like just in between the 2. Again, so most of the Colorado Plateau, that's due to sedimentation and volcanics. The transition zone is just kind of its own thing, but the Basin and Range Province, where Phoenix and Tucson and Yuma and places like this, even getting into other areas like Las Vegas, parts of California, on up through Nevada and parts of Utah. So most of that terrain in the Basin and Range Province, for example, Phoenix and Tucson, is due to plate tectonics. Most of the terrain in the Colorado Plateau is due to volcanism and sedimentation. Sediment being deposited, forming sedimentary rocks. More on that in a later unit. So, the Basin and Range Province is a pretty interesting geologic province, geologic area. It extends from Mexico all the way up into Oregon and Utah. And a lot of area in this looks very similar. If you're driving through Nevada, a lot of it looks terrain-wise, geologic-wise, like Phoenix. If you're in Las Vegas and kind of look around, flat, and then random mountain ranges popping up, just like Phoenix, just like Tucson. So, the Basin and Range Province. So how did it form? How is this due to plate tectonics? Well, we can actually thank the San Andreas Fault. There's a lot of steps that go into this. This is a branch of geology called historical geology, which we will start to offer a new class, GLG102IN integrated, that kind of covers this. But just long story short, so we had movement along the San Andreas Fault. So once this transform movement occurred, this side-by-side movement occurred, it caused the western states to look the way it did. So what happened? Once the transform boundary formed and movement occurred, that actually helped to release some pressure on the western U.S. So that transform boundary runs right around here. Once that movement occurred, it kind of released some pressure on the western U.S., causing it to kind of settle and relax. All right, you can imagine like something kind of really kind of held together, being squished together, and all of a sudden, if there's a relaxation of that, well, the western portion of the continent, I should say, began to kind of spread out and relax and extend. Not only was there a relaxation, but also that transform movement, that grinding movement, not only helped to relax and extend the continent, it actually helped to kind of pull it along a little bit. As the Pacific plate is grinding, it kind of pulls on North America, helping it to spread out a little bit. So we exhibited, or there exhibited extension. So the western U.S. was starting to get kind of pulled apart. And as it did, it started to crack. And as the western U.S. began to crack, some material dropped down, and that became the flat basins. Some of the material, as it cracked, stayed up or got pushed up. Those became the ranges or mountain ranges. So that's what we see in the western U.S. So that's why driving around Phoenix, flat desert, high mountain range, flat desert, high mountain range. You drive from here to Tucson, flat desert, mountain pop up, flat desert, mountain pop up, flat desert, mountain pop up. It's the Basin and Range Province. Again, as the movement along the San Andreas occurred, it allowed the western portion of the North American plate to stretch thin, and causing the crust to fracture. Some of that material dropped downwards, some of that material went upwards, so we have the basins dropping down and the ranges popping up. That's in essence how the basin and range formed. There's a lot more that goes into that, but that's why we owe, the Phoenix area, Tucson area, most of southern and western Arizona, all of that geology is due to plate tectonics, movement of plates creating this. Now, these are some videos of that I want you to watch in regards to the basin and range, how it occurred. Here's also a geologic map, which is a map that shows the surface geology, or the geology just below the surface of Arizona. In fact, let me see if I can open it up real quick. Okay. What I really want to go down to is down here. So these are cross sections. So looking at this geologic map of Arizona, there's this line A to A with a little apostrophe. That's A prime. And then we have the line B to B prime, and then C to C prime. I'm going to look at this this line C to C prime. What these cross sections are, imagine Arizona was sliced along that line, and then we kind of tilt it and look at it from the side. It's almost like looking down at a cake, cutting into it, and then looking at that cake from the side. So same thing here. We're looking at Arizona, the surface geology of Arizona. All these different colors indicate different rocks. If I were to slice Arizona here and then look at it from the side, this is what I would see. This is what I would see. So we see the Basin and Range Province. We can see some stuff went up, some stuff went down. Some stuff went up, some stuff went down. Some stuff went up, some stuff went down. Very typical in the Basin and Range Province. And then when you get up into the Colorado Plateau, mostly flat-ish. You don't see any up and down movement underground. This is some volcanic activity, more typical in the Colorado Plateau. So also something you can look at as far as understanding Arizona's geology, these different types of cross sections. Please watch this video. Let's see. Can we watch this one? Let's see. Let's see if I can get it going here. Make this nice and big. way and then start here. Well, you can watch it and I'll kind of narrate it for you here. So again, downdropped basin, uplift in ranges, very common, it exists in the western U.S. due to this crustal extension, and they're going to show you a diagram of how that occurred. So the before extension, then you get the movement along the San Andreas, which relaxes the pressure on the plate and also helps to pull it apart. So you get the plate stretching, hot, it starts to thin out. As it begins to thin out, mantle material kind of makes its way up, which facilitates the kind of thinning and cracking. Some material gets thrust up, some material kind of falls down. So mountains rise, valleys drop, valley of the sun, and that's where you get your basins, low-lying area, and the uplifted ranges. So you can see before extension and after crustal extension, all thanks to the San Andreas, 30%, Western North America extended by 30%, and that's why we get all these basin and range province. All right. So, we are in the midst of the tectonic cycle. So we're going to talk about, how the mantle doing what it did, melting material, creating magma, which can create volcanoes and igneous rocks. And we'll talk about igneous rocks in a later unit. But coming up here, we'll talk about volcanoes and earthquakes and some of the following units. Seafloor spreading, what it's causing, subduction, convergent boundaries, what's happening to oceanic crust, melting, all of this material. So this tectonic cycle is really tied into the rock cycle. So for the next few units, we're going to talk about volcanoes and earthquakes, and then we'll get into how that tectonic activity, that tectonic cycle causing volcanoes and earthquakes, is causing and creating the rock cycle, creating all these different types of rocks. So we'll spend the first section of our semester kind of in this tectonic cycle. Now, since plates move around, I usually get the question, well, what's Earth, if the plates are moving around, what's Earth going to look like in the future? Great question. So here's future world, 250 million years into the future. Pangea Proxima, just kind of a made-up name. So this is approximately what the new supercontinent will stand for. Pangea is Latin for all Earth. So this is approximate some approximation of all Earth once it comes together 250 million years into the future. North America, South America, Africa, Eurasia, Australia crashing into Antarctica. So yeah, there you go. There you go. So let's reflect. What are some of the big or main ideas as it pertains to plate tectonics? Remember, these big ideas, these main ideas are what I will assess over when we have tests. Questions will only be kind of based on these topics. So make sure you're comfortable with these topics. Go back through the material again and focus on this stuff. Plate tectonic theory, highest level of knowing. We talked about that in section 1 and 2. Past evidence of Pangea, current proof and movement. Mantle convection, that was section 3. How it works, how it's similar to a lava lamp. Use that as your guide, as your model, about some heat source driving that convection process. That convection process causing the plates to move around, and what type of boundaries do we have? So convergent, divergent, transform, maybe some examples of those around the world, what kind of things they cause, earthquakes, volcanoes, etc. And the basin and range formation, movement along the San Andreas, relieve some pressure, cause crustal extension, the crust cracks, some material got thrusted up, those are your ranges, some material fell down, those are your basin and range province. So on the big ideas, I'll put a little Arizona flag if it has something to do with Arizona. That was section 5. All right. Well, that's another unit in the books. Make sure to get on that assignment. Again, this unit, this semester, this class goes pretty fast, so make sure you're just tackling one thing after the next. So it's been fun. Until next time, I'll see you again. It's Mr. K signing off. Adios.